Another important part about green IT is to really understand how products themselves are being redesigned for energy efficiency and for better power consumption. So what we're going to walk through here are some of the things that are happening in hardware and software. There's two high-level goals at the core of this. First is to yield more compute power per kilowatt. Second is to actively monitor and manage energy usage. So first of all, now let's walk through the hardware issues and some of the things that are happening in the industry. Server performance and density is increasing, so what you're getting is less space, higher performance, lower power consumption. And with this, you get reduction in frequency and voltage of the CPU, intelligent aware processors, and built-in statistics such as voltage, watts, and temperatures, which can be utilized later by software. Blade servers have the ability to reduce power and cooling requirements by 25 to 40% in some cases over 1U technologies. Multi-core processor servers, mainframe systems are being introduced as green IT strategies are being deployed. Storage is a big issue, minimizing spinning disks and tapes. Performance-oriented storage, which is heavy on DRAM. If you look at that, there might be one relative power unit. Then there's capacity-oriented storage, or RAID, which is about 1/8 relative power unit. And then there's power-oriented storage, or MAID, 1/64 the relative power unit. So many different storage technologies depending on what the application is. Looking at cooling, closely coupled cooling, so coupling the cooling with the rack itself, liquid cooling inside the rack itself. Another problem that we see in hardware solving is limiting the number of AC to DC power conversions that are happening in the data center itself. So by moving to DC powered servers, we can sometimes reduce this number of conversions by at least 3 times. Right-sizing the server farm can eliminate up to 50% of electrical bill in real-world scenarios. And finally, the Green Grid, which is an interesting industry organization, is proposing component efficiency standards for a large number of hardware components in the enterprise data centers, many of which we just chatted about. Now let's take a look at software. Software is, in many cases, just as important as, if not more important than hardware in many cases in the enterprise data center. One of the first things and most useful strategies and products going forward is going to be active energy management software. So what this does is it allows the enterprise IT manager to monitor, measure, and control energy usage, identify and compare actual power used, view inlet and exhaust temperatures, track heat emitted, and things like trending power use and temperature usage over time. So very good statistics to have a better understanding of exactly how the hardware is operating. Another important piece of software is accounting, monitoring, and provisioning. So things like actively moving workloads to underutilized servers, automatically powering up and down resources. Virtualization is another thing which we talked about in detail earlier in the presentation. Another component is software intelligence to move data queries to off-peak hours for compute-intensive database servers. Things like intelligent middleware for transaction management. This is more of a development process, but it's to build application footprints for low power consumption. And finally, intelligent policy-based software to monitor transactions with energy and thermal dynamics in mind.